In this video, we'll cover Chapter 6 on labor markets. What we're doing at this point is we're moving from the short run to the medium run. So we're going to talk a little bit about what the equilibrium looks like in the medium run. And what distinguishes the short run from the medium run? The medium run is simply the time it takes to return to full employment. Now, in our model, what that's going to mean is the price and the expected price are the same in the short run. One of the reasons we're not at full employment is for some reason the price and the expected price may not always be the same. So that'll cause short-run deviations from the full employment level. But in the long run, price and expected price will be the same and we'll return to full employment. But the main message here is simply that the medium run is the time it takes to get back to full employment. So let's look at Chapter 6 on the labor market. And we'll just go straight through the chapter. We're going to start with section 6.1 and just move on through. This is just an overview. Look at what the labor market actually looks like. So what we can do is we can start with the entire population. So the population of the U.S. in 2010 was estimated to be, let's just say was, 308.7 million. Now, we want to look at the people who could possibly work. So what we can define next is called the civilian, non-institutional population. So we're going to take away people in the military, people in hospitals, mental hospitals, those sorts of things, because they're not going to work. They're out of the population of people who could ever work. And we're also going to throw out the people who are under 16. So it's the non-institutional civilian population that are over 16. Because again, we don't think that kids are part of the workforce. I mean, some work a little bit. But for the most part, when you're under 16, you're not allowed to work. So when we move from here to here, we drop down to 237.8 million. Then we can divide this into two boxes. And then I'll have two more under this in case you need to know how much room to take. So we'll break this into two pieces. The first piece is the civilian labor force. This is the population. This is the labor force. And that turns out to be 153.8 million. Not quite, a little over half of the total population is the people who are actually in the labor force. Then there's people who are out of the labor force. For some reason, they don't want to work. They just, got enough money, they don't need to work, or there's some other reason, So that number turns out to be 84.0 million. Then we can break this last box into two pieces as well. The labor force, we can split into the employed and the unemployed. And the employed turned out to be about 139.0 million, and the unemployed was almost 15 million, 14.8. So this is all for 2010. So in 2010, we had almost 15 million unemployed people. That's a little less now, but at that time, we had that many people. Now, from this, we can do some calculations. Let me leave the numbers on the board. So the unemployment rate would be the 14.8, the number of unemployed, divided by the labor force, 153.8, and that turns out to be about 9.6%. So the unemployment rate was still pretty high in 2010 because we're still recovering from the Great Recession. You often see something else called the participation rate. And that's defined as just the number of people in the labor force in the population that are participating in the labor market. So that's 153.8 divided by 237.8, and that turns out to be 64.7%, which is actually historically a little bit low, partly because of the recession. But so that's this number divided by that number. So you take the population who could be working, and you divide it by the number who actually want to work. This would be the non-participation rate would be that over that. And then something that's a nice indicator of how things are doing is the employment to population ratio. And the employment to population ratio was 139.0 divided by 237.8. So it's not the total population, it's the population of people who could potentially work. And that was 58.5%. And that's very low historically, again, because of the recession. And so that's just a picture of how the population breaks out into, you know, the people who could work, the actual workforce, the people who don't want to work, and then in the workforce, the people that are employed and unemployed. And then these are the three main statistics you usually see to characterize the labor market. How many people are participating, what's the unemployment rate, and of our total population, how many of those are actually employed and working and providing the income that everyone needs to live. All right. Those are stocks. You can also look at the flows in and out of a lot of these categories. So let's do another graph. These are all in your book, I believe. They are. That's where I got the numbers. Let's look. These are average flows. You'll see what we're going to look at here in a second. Let me just tell you the time period. From 1994 through 2011. I really don't like that they're mixing up recession times with non-recession times, but I guess that's okay. So these are averages, so the numbers are going to be a little bit different from what we just saw. The employed, last was just 2010. This is an average over the whole period. Employed was 132.4 million. Unemployed was 8.4 on average. 2010, it was almost 15 million. So you can see that the average number of unemployed was way below what it was in 2010. And these are the out of the labor force. And that was 73.3. But there's a lot of flows within here. One, I'll explain what this is in a moment. That's 3.1 million from the employed. These are the people that get fired or quit and then get rehired within the month. So they just go from one job to the next. They're really not unemployed for any period of time, not long enough to be caught in the surveys, not even for a month. And so you can just think of these as 3.1 million people on average each month will go, so these are monthly averages, will go from employed to employed. 1.8 million people go from employed to unemployed, and about 2.1 on average during this time go from unemployed back to employed. Of the unemployed, some of those will leave the labor force. Maybe they get discouraged, they can't find a job, so they say, oh, I'm going to stop looking, and they go out of the labor force. Other people return. These flows are pretty similar. That's 1.8 million. And then we have two flows. Some people, they're out of the labor force, and they get a job, but they don't actually spend any time unemployed. They just go straight from out of the labor force into employment. That would happen if you got a job, for instance, straight out of college, and you never really had to search. But that's not the only way it can happen. So quite a few people, 3.3 million on average each month do that. And there's a similar number that go in the other direction, even more, 3.6. So these are people that were working and they just left the labor force completely for some reason. Okay? Now, what this means is that on average, there are 8.5 million separations each month. Separations from employment. That's the 3.1 are the people that are separated from one job and go right straight to another job, plus 1.8 become unemployed, and 3.6 leave the labor force altogether. If you add those up, you should get 8.5. So there's 8.5 million separations each month. That's a huge amount. So if you think about what the unemployment rate is 8.4. What the point of these numbers is there's a heck of a lot of churn. Although the unemployment rate is 8.54 million, it's a bunch of different people each month. Millions and millions of people become unemployed, and millions of people find a job each month. So the flows in and the flows out are actually fairly significant each month. In fact, look at the flow out of unemployment. Let me just put a little box here and keep it separate. So let's look at the flow out of unemployment. So these are the unemployed people. 2.1 and 1.9 are the flows out, right? So 2.1 people get a job, 1.9 leave the labor force. So that's 4 million people each month who leave the roles of the unemployed. That's almost half. Turns out to be 47%. So 47% of the unemployed from month to month find new jobs or leave the labor force. Some of these are discouraged workers. They quit. But for whatever reason, either you get a job or you become discouraged, 47%. And these aren't all discouraged. Some just decide they don't want to work after all. But 47% of is the monthly turnover in the unemployment rate, which is pretty high, probably higher than you would have guessed. The flows in and out of the labor force are also relatively large. I'm running out of space, so let me look at flows out of the labor force. That is 3.3 million people get jobs, and 1.8 re-enter the labor market, but they're unemployed. They start looking for jobs. So 5.1 million is the flow out of the labor force each month. If you look at the flow into the labor force each month, again, these are averages. The flows in are 1.9 come from the unemployed, and 3.6 come from the employed. So you get 5.5 million, which is a fairly large number. So in all of these categories, either in and out of employment, in and out of the labor force, in and out of unemployment, the average flows from the 94 to 2011 period are actually pretty significant. They're pretty big numbers, particularly here. And one other thing, let me say one other thing about this. We said the flow out of unemployment was 4 million. So a lot of people get jobs each month, about, as we said, 47%. But there are also quite a few people who are chronically unemployed, and they tend to have really, really long unemployment spells. And so you sort of have a thin middle. You have a bunch of workers who get jobs really fast, and a bunch of workers who really have trouble getting jobs, and there's not as many in the middle. And in fact, the stock of the long-term unemployed during the Great Recession hit record levels. There were a lot of people who just couldn't find jobs no matter how hard they tried. Okay, let's look at movements in the unemployment rate next. Now I'm going to need you to pull out your book if you have it with you. You can just put the video on pause because I don't have a good way of putting up this graph that I want to look at. But this is the graph. Where did I put it here? This is the graph on page 115. It's figure 6.3. Looks like this, if you can see that. That's the one I want you to look at. And there's several things we can note about that graph. So the topic here is movements in the unemployment rate. And it's in reference to, and the section is talking a lot about what's in that graph, the graph 6.3. So the first thing you see when you look at that is until the mid-'80s, it looks like the unemployment rate is increasing on average. So what we mean there is if you look at this left-hand side of the graph, I don't know if you can see it, up until the 80s, it looks like the average is rising. Then you get a big fall. So it looks like the natural rate of unemployment is going up. It's about 4.5% in the 50s. 1950s is about the average unemployment rate. It's 4.7 in the 60s, 6.2 in the 70s, and 7.3 is the average unemployment rate in the 80s. So for some reason, and part of it could be demographic change, lots of women entering the labor market, lots of baby boomers. When you have lots of first-time workers, like people just getting out of college, they tend to change jobs a lot. You get a lot of churn. And so that boosts up the average unemployment rate. So part of this might be demographic. Part of it might be structural. There's a lot of structural change going on, inventing new things. Going in the 70s from a steel-producing nation till now, and really industrial and cars, to now where it's much more service-oriented. That structural change might make a difference. And so, but for whatever reason, it looks like as we go from the 50s to the 80s, the average unemployment rate's going up, and you can see that in the graph. From the 80s on until 2007, when the Great Recession hits, it looks like the unemployment rate begins declining again on average if you look at that graph. And then it spikes in 2007 with the Great Recession. And the other point we want to make here, and I think I've run out of room on the board, so I have to erase some things, is that the movements in the unemployment rate closely follow recessions and recoveries. So movements in the unemployment rate follow expansions and contractions pretty closely. I talked a little bit about some of the deviations in the last two recessions in the very first lecture, but for the most part, partly because the definition of recession means unemployment rising, and so this shouldn't be surprising given how they define they look at four things basically. Two of the things they look at to define recessions are the unemployment rate and output. So it's not surprising that if unemployment's going up, that's probably a recession, and if unemployment's going down, that's probably a recovery. And so you see that in the data, but again, that's probably not that much of a surprise. All right, now let's ask a different question. Are movements during expansions and contractions, movements in the unemployment rate during expansions and contractions, mostly due to layoffs going up or hiring falling? So those are the two flows into unemployment. And is it because less people are coming out of the unemployed because they're hiring less? Or is it because more people are going into the unemployed? Now, I would have thought long ago that it was mainly due to hiring or layoffs. that what happens is you hit a bad time and they start firing people. But that's actually not what happens. What happens is the fall in hiring is the main thing that causes the variation in the unemployment as we go from booms to recession. So it's mostly variations in the hiring rate that we see that cause variations in the unemployment rate. It's the uptake rate, not the rate at which you're firing people. Though in severe recessions like we just had, this matters too. But even then, hiring changes are a bigger part of the story. Let me say this differently. It's both. Hiring has the biggest effect, but even in recessions, this matters too. Let me just say in recessions, it's really both, but I think hiring has a little bigger, a little bit larger effect. Let's talk about this a little more. Let me straighten this up. Straighten this out. All right. When hires go down, the chance of finding a job goes down. And so the unemployed pay this cost. If you're unemployed and the hiring rate goes down, then you're the one paying the cost because it's less likely. Some of those unemployed that would have gotten a job don't because they're hiring less people. So if it was all the higher rate that was causing the variation in the unemployment rate, then if it's all the higher rate changing over expansions and contractions that's causing the change in the unemployment rate, then the unemployed are paying the cost. When layoffs go up, that's bad for workers. So workers pay the costs. So in one case, the workers are paying a cost, and the other, the unemployed are paying the cost. And so the question we're trying to ask here is, who pays the cost of recessions? And this is where, if you turn to figures 6.4 and 6.5, you can see the answer. They're on the next 2 pages of the text. It's, and although I said it's mostly the hires, I think that's right. This shows that in general, it's not just hires, it's both. So what they've plotted is the layoffs over time and the hires over time, along with the unemployment rate. And what you can see is that in both cases, though I think it's a little stronger with a higher rate, the two series track the unemployment rate fairly closely. So when the unemployment rate's going up, you see the layoff rate going up and the higher rate going down, and so on. And so if you look at how those things co-vary with the business side, how unemployment co-varies with layoffs and hires, you'll see that the cost of unemployment is really paid by both groups. So earlier I said it was all hires. I misspoke when I said that. Okay. Let's move on to the next topic, wage determination. I need to get a drink of water here. One second. I've got some water off camera where you don't have to watch me drinking it. It's actually a Diet Coke. Right back. There it is. So now we want to figure out, remember the big topic here is labor markets. We want to figure out how are wages determined. So some facts to begin with. The first is that the wage that's actually paid is in general greater than what we call the reservation wage. And that's the wage that makes a person, that makes you indifferent between working and not working. So if someone says, hey, I'll pay you $7 an hour, you want to work? And, oh, God, I don't know, that's just hardly enough to, I don't know, and you just can't decide. Maybe, yeah, I don't know. That'd be the reservation wage. If they actually pay you $12 an hour, then you're getting paid $5 above the wage it would take to. So at 7, you're indifferent. Okay, let's pay you 7.25. Okay, that's enough. So that in anything above that, you'd be above your reservation wage. So anything over that $7 minimum wage that would make you indifferent. At $6, you just say, nah, I don't want to work. Sorry, go ask someone else. You need to pay me more than that to get me to work. And so the reservation wage, the wages actually paid in labor markets in general greater than this. We'll talk about why later. There's a couple of reasons for that. Secondly, wages typically depend, this shouldn't be a surprise, wages typically depend upon labor market conditions. Wages are higher in booms when labor markets are tight than in recessions when labor markets are loose because there's a lot of unemployed. And so, in essence, when the unemployment rate goes down, we tend to see wages going up. Though as we recover from the Great Recession and the unemployment rate's been falling, wages have not been rising. So there may be a threshold effect that we have to cross before this takes hold. But for the most part, that's true. Okay, a third fact for us is that in the US, labor unions are not very important. Only about 10% of workers are currently in unions. A lot of those are public unions, government jobs. And so it's just not a very large factor in wage setting. So that brings up a question. So this brings up a question. If labor unions are unimportant, and there's little apparent bargaining power for firms, they don't have any collective bargaining power, why are wages greater than the reservation wage? Why pay someone $12 an hour if you can get away with paying them $7? And there's two reasons. Even without unions, workers typically have some bargaining power. We'll talk about this in a second. We'll explain why in just 1 second. And second is something called efficiency wages. So let's talk about those two things. So first is on bargaining power. How much bargaining power a worker has this is how much bargaining power a worker has depends on two things. First, how costly it would be to replace the worker. So if the job requires a lot of specialized training, a lot of on-the-job training, so you took your worker and you sent him to all these schools for a year or two, then that worker is going to have a lot of bargaining power, because if he or she threatens to quit, it's going to cost you a whole lot to retrain a new worker. If, on the other hand, there's a bunch of workers out there that know how to do this stuff, that worker is going to have a lot less bargaining power, because if they threaten to leave, you say, fine, go ahead. I got someone out here that's unemployed. They'll take your job. They'd love to have it. And so the cost of replacing a worker is going to be important. And how hard it is to find for the worker, how hard it is for the worker to find another job. So you have a lot of specialized training, and you go to the boss and say, you pay me more or I'm going to quit. And the boss says, we're in a severe recession. You've got a family. Where are you going to work? No one's going to hire you. If you're near full employment, though, and you go and say, okay, I'm going to quit, and the boss says, go ahead, and you do, because you can find another job fairly easily. And so either pay me more or I'm going to quit. I've got another offer over here. They're offering me $14 an hour. You're paying me $12. Either pay me more or I'll quit. And so the threat is much more credible that you'll quit when the labor market conditions are good. So this has a couple of implications. So there's two implications of this, at least. So this tells us that bargaining power, already alluded to this, depends upon the nature of the job, so this is that idea that training and how specialized your job is matters. So a worker at McDonald's is going to have a lot less bargaining power than a worker that has a lot of really specialized training that nobody else has. It's because the worker at McDonald's would be easy to replace. The other worker would be very hard. That's going to give you much more bargaining power. And bargaining power depends upon labor market conditions. This is how easy it is to get another job. This is a bit repetitive, but again, I'm just following the book. And so those are the implications of this. Okay, let's talk about the second effect, which is efficiency wages. The second reason why wages are greater than the reservation wage could be because of reservation wages. So firms may want to pay more than the reservation wage for the following reason. When wages go up, costs go up. But sometimes when you pay people more, this is the Henry Ford story, you get much more out of them. They work harder, they're more productive. You've got this job, the boss is paying you way less and you think the job's worse. Yeah, I'm not going to work very hard. I'm paid so little, I don't really care. Fire me if you want. I'm just going to do the minimum I need to do to get by and screw this job. And fire me if you want. I'll just go get another crappy job somewhere else. But if you double, triple that wage, maybe the worker says, oh, wow, I've got a really good deal here. I better work my butt off to make sure I keep this job. And there's other ways you could tell the same story. So when wages go up, you often can see productivity going up. And that causes costs to go down. And sometimes this effect can dominate. And so when it appears that you're in an industry where the productivity effect is going to dominate, you can motivate people by paying them more to work harder, then that's going to lower your costs more than the increase in the wage is going to cost you. And so it's worth it. I mean, overall, your costs have fallen even though you've raised your wages. And the other reason, so this is one thing. The other is that it decreases the turnover rate. If people are getting a good deal at your firm, they're much, much less likely to quit and try to work somewhere else. And I guess the most general way to say this, so more generally, firms want workers. It's optimal for firms to want workers to feel good about their job, to want to work there, to want to work hard. And that's particularly true in some areas like high tech. I mean, you see all these, in Google and places like that, these really good treatment for their workers. Well, those workers, their motivation really matters. And so when morale and commitment to the job are essential, you tend to see firms paying more. So those are reservation wage. Again, this will also depend upon labor market conditions. Now, what we can do next is we can summarize. We're going to capture the previous discussion with an equation. With the wage equals the expected price level times some function of the unemployment rate and Z. So this is expected price. I'm going to explain each of these terms in a second. This is the wage that you earn, the nominal wage. This is the unemployment rate. And this is a catch-all term. And we'll talk a little bit about some of the things it catches in a second. So let's talk about each of the terms in this equation. The signs are, this is positive, or negative, this is positive, and this is, of course, positive. So when the expected price level goes up, you tend to see higher wages. When the unemployment rate goes down, you tend to see higher wages. And when Z changes for any of the reasons we'll talk about, you'll also tend to see higher wages. And we'll talk about what's in Z, as I said, very shortly. So let's start with the expected price level. Why is it the expected price level? Well, the first thing is that workers care about real wages. Wages deflated by the price level. They care about purchasing power. They don't care about the nominal wage. They care about their purchasing power. What's important when you're negotiating and thinking about a wage is how many goods and services that wage will buy you. And so it's the real wage that matters. Now, the way it works is that usually you set So this is a timeline. This is T plus 1. This is, January next year, and this is January this year. Usually wages are set here, and they're constant, and then wages are reset here. What matters is the average price level during this time period, because you want to take the wage you're getting. If you live in an economy that has 100% inflation per year, you're going to want a much higher wage than someone who lives in an economy with zero inflation, because you have to ask for enough wage to cover that increase in the price level so that you can buy the right amount of goods and services that you're planning. And so what matters is the price in here, but the price is unknown. You don't know for sure what the price level is going to be on average, because it's in the future. You're setting the wages today for a whole year. And so you have to guess what the price level will be, and that's why it's the expected price rather than the actual price. The second factor was the unemployment rate. So that's the PE term. It was PE, F of U and Z. The second thing is the unemployment rate. This is obvious. When the unemployment rate goes up, we tend to see wages going down because workers lose bargaining power. And so I don't think this needs much explanation. As the unemployment rate goes down, it's harder and harder to find workers. That tends to push the price of labor up and push wages up. So that seems fairly straightforward. And then what are these other factors? Z. What's in Z? Z is all the other factors. Again, this is just a catch-all term. And in there are things like unemployment insurance. We would expect that as unemployment insurance goes up, it gets better. It's going to be harder to get workers to leave the ranks of the unemployed. They can wait for a better offer. If you give them a crappy offer, they don't have to say, oh, I'm getting zero money. I got rent to pay and kids to take care of. I better take this crappy offer. If unemployment compensation is better, then they can say, well, I'm pretty sure I'm going to get another offer before my unemployment compensation runs out. So I'm going to wait and see what I can get, because this offer is just not good enough. And so unemployment insurance leads to better matching, because workers don't have to take a job they're not well suited for. So it has some good things, but it also tends to raise the unemployment rate. So what this does is when unemployment insurance gets better, it tends to cause firms to have to make higher wage offers in order to get people to work for them. Another one might be the minimum wage. This one's obvious. Sometimes what matters is the distance between wages. People want to know, oh, I'm making $1 more than that person. If you take the bottom wage and you push it up, that tends to push up the whole wage distribution. So if the minimum wage goes up, the whole rank order has to go up, and that tends to raise wages. If employment protection goes up, workers are protected from being fired, for instance. That gives them more bargaining power, and that would tend to raise wages. And we'll look at some other things later. Okay? Just trying to see if I should break this up into two pieces or not. Let me do one more thing, and then I'm going to save the rest for a second video, but the second one might not last a full hour. That's okay. We'll just have a shorter second piece. Maybe I'll put them together. We'll see how long it is. Okay, there's a second equation that we need to get to. Next, we want to talk about price determination. So that was the wage setting equation. Now we're going to talk about price determination. So costs depend upon the nature of the production function. We're going to assume a really simple form for the production function. We're going to assume that y equals a times n. This is labor. This captures labor productivity. As technology improves, A might change. We're going to hold technology constant. And this is output. So all we're doing is writing down a function that turns N, labor, into output. Now, more generally, you might want to have capital in here in other inputs. Labor is the main input. It's the biggest cost. It's about 70% of a firm's cost. I think somewhere in the chapter it shows you that. So we're just going to focus on labor. But there are more general forms of production functions that you could use. Now, to simplify, we're going to normalize. You can always change units. So this is true to have A equal to 1. So our production function is just going to be y equals n. Output equals the number of labor. You could measure this in hours. You could measure this in 2 hours and 3 hours. All you have to do is just measure it in a way so it comes out that y is the amount of produced, 10 is equal to 10. So 10 whatever labor units give you 10 pieces of output in some time period. So that's going to be our production function. It tells us how labor turns into output. It tells us how much labor it takes to produce a given level of output. Now, hopefully you remember from principles that under pure competition, price is equal to marginal cost. And here, the marginal cost is just the wage. So you would get that price equals wage. More generally, you probably looked at something that when you took micro, you probably said W equals price, which is what we have here, times marginal product. But for the production function that I've used, marginal product equals 1 when y equals n. So in the simple model we're looking at, wage and price would be the same because the marginal product is 1. When y equals n, if I increase n by 1, y goes up by 1. So the marginal product is just 1. And so this is the general form of it. But we're taking a really simple case. We don't have to worry about the productivity. We're holding productivity constant anyway until we get to the growth chapters. We'll relax that later. So for now, we're just making a very, very simple assumption. So price equals wage if it's pure competition. Now, what you should have learned in micro 2 is that, not micro 2 like Roman number 2, but TOO. What you also should have learned in micro is that when markets are non-competitive, they're not non-perfectly competitive, like monopolistic competition, a wedge gets drawn between price and marginal product. So in that case, price is equal to 1 plus m times W. What happens in this case is that price will be greater than marginal cost. So when you have non-competitive labor markets, price is greater than marginal cost. This is the marginal cost. M is positive, so it's telling us for pure competition, M is 0. M is the degree of monopoly power. As monopoly power gets bigger and bigger, so this is the degree of market power. As market power gets bigger and bigger, the wedge, the difference between price and marginal cost, gets bigger and bigger. So a pure monopolist, this will be a big number. Pure competition, it collapses to 1, and we're back to P equals W. So this is the form we're going to use right here. So when you have market power, price is greater than marginal cost. I'm going to keep going here. I don't have very much left, so let's just finish it off in this one video. Okay, now we can put all of this together and draw a graph of it. So we can put these two equations together that we've looked at. So let's find, we're going to find the natural rate of unemployment is our next task. So we have one equation that says W equals PE F of U and Z, and another that says price equals 1 plus M times W. For now, we'll relax this later, assume that the price equals the expected price. That is, assume we're in the medium run. That gets us to full employment in this model. So I can replace that with a P. So now I have W equals PF of U and Z, and P equals 1 plus M times W. Let's rewrite those equations in a simpler form. Let's work with the second one first. So from this equation, we can say W over P equals 1 over 1 plus M. So I bring the P down under here, the W over P, bring this to the other side, 1 over 1 plus M. I get that equation. So this gives the real wage firms pay. This is sort of like a labor demand curve in some ways. It tells us the wage they're willing to pay depends upon the degree of market power. As market power gets bigger and bigger, this wage gets smaller and smaller. They have more market power, they can squeeze that wage down a little bit. The other equation tells us that, this one tells us that W over P equals F of U and Z. So now we have two equations with the same thing on the left side. If I set those equal, so I can set these equal. F of U and Z equals 1 over 1 plus M. So if I plug in M, the average degree of market power in the economy, and I plug in all these other factors, this will give me the natural rate of unemployment. Because price is at the expected price, so we don't have to worry about being away from the long-run equilibrium by definition. And so the way this works is we just give it an M, give it a Z, and it gives us the natural rate of unemployment back. So Z is all those things like unemployment compensation and minimum wage and all these other things. This is that affect the supply of labor. This is what affects the demand side of the labor market. And you put those together, it looks like that. We can also do it graphically. So what we can do, we want to find the unemployment rate. We're going to put W over P on this axis. This is the price setting equation, PS. This is 1 over 1 plus M. That's from W over P equals 1 over 1 plus M. This is a horizontal line. It doesn't depend upon U at all. So this is W over P equals 1 plus M. Once I know M, it just gives me a wage. And the other thing is the wage setting equation, WS. This was PS. The wage setting equation is W over P is F of U and Z. That's the wage setting equation. And remember, this was a negative effect. So when U goes up, the wage goes down. So the wage setting equation is negatively sloped. Where they're equal, where this equals this point here, gives us the natural rate of unemployment. So that would be the natural rate of unemployment in this model. So the equilibrium in the labor market, once we know the degree of market power, and we know unemployment compensation and minimum wages and all the things that affect bargaining power and the like, we can put that all together and figure out what the natural rate of unemployment is going to be. And this is what the real wage would be. This is equal to W over P. So we have that amount of unemployment and that amount of real wage. So that's the equilibrium. Then we can use this graph to ask about what will happen when things change. You know, one thing about doing these on video, and I'm teaching an actual class, I can look out there and if people are writing madly and their heads are all down, I can kind of slow down and pause and let them get their notes all taken. And then sort of, so the pace is a bit slower for that reason, because you just naturally see people and their heads are down and they're scribbling as fast as they can, say, I can't go on yet because they're still writing down the stuff I just said. And you tend to pace yourself. What I'm hoping you're doing is using the pause button to just pause the videos when you need to keep scribbling. You can also do what you can't do in a lecture, which is back it up and rewatch sections. And so for those two reasons, I'm not as concerned about, I'm a little bit concerned I'm going a little faster than I do in a regular class, but hopefully you're able to use the technology to make the information come at you at the pace you need. I mean, if you need to watch a section 3 or 4 times to get it all down, just do that. That shouldn't be an issue. Okay, we can use this model to look at what reasons why wage and or natural rate of unemployment changes. For instance, let's look at a first example. This will be a shift in the F function. What if unemployment compensation gets better? That is, Z goes up. Well, in our model, what did we have? We have the price setting equation, the wage setting equation, which is F of U and Z. This was 1 over 1 plus M. Again, this is 1 over 1 plus M. And that's Z0. And that gives us the initial unemployment, natural rate of unemployment, UN N0. And then when Z goes up, unemployment compensation gets better. That's not going to change the wage, which is fixed because we don't have any slope to this thing, but it will change the unemployment. So this will shift out to F of U and Z1 because Z went up, and the natural rate of unemployment goes up. The real wage would be the same. So any shift in Z, you know, if the minimum wage goes up, the same thing would happen. And so on. We can look at this. We can also look at what might happen. Suppose that a new administration is elected and antitrust enforcement is less stringent, goes down. That's equivalent to M going up. What would that do? So that because we're not going to enforce the antitrust laws as stringently, that's going to cause M to go up. So that's going to cause, here's PS0 and WS0, and here's our initial unemployment rate. This is 1 over 1 plus M naught. If M goes up, what happens to the price setting equation? Well, clearly it shifts down because the thing on the bottom is bigger. So after this change, we get a new price setting equation. And in this case, the real wage goes down the real wage falls, and the natural rate of unemployment, this is the natural rate, and 0, 1 goes up. And so in our model, that would be the effect of a change in the degree of market power. Okay, just two more quick things, and we're out of here. From unemployment to employment. What's the natural rate of employment as opposed to the natural rate of unemployment? Remember that the unemployment rate is the number of unemployed over the labor force. That's equal to the labor force minus the number of unemployed over L. So the unemployment rate is equal to wrong, L minus N. L is the labor force. We've been using L. I suddenly switched to LF. Let me get the notation like we've got in the text. It's that. L is the labor force. N is the number of employed. So the labor force minus the number of employed is the number of unemployed. I put the number there because I'm using two U's and I don't want them mixed up. So the unemployment rate is equal to, if I divide this out, it's 1 minus N over L. That tells you that N is equal to L times 1 minus U. So if I know the natural rate of unemployment, I also know the natural rate of employment. For instance, if the labor force is 200 and the natural rate is 5%, I can use that to say, well, the natural rate of employment is 200 times 1 minus 0.05, which is 190. So 190 would be the natural rate of employment if the natural rate of unemployment was 5%. Now, what we really want to do is write this in terms of output because it's going to be really useful in the next chapter. So now let's go from employment, N, to output, Y. Why? I'm going to tell you. All right, so we know that Y equals N. So it must be that Yn equals Nn. The natural rate of output is equal to the natural rate of employment in this model. And we already worked that out. That's L times 1 minus mu N. So now we can write the labor market equilibrium as 1 over 1 plus M, the price setting, equals F of U, but U is 1 minus Yn over L. If you remember from the equation we just did, we just showed that Un is equal to 1 minus N over L, and Nn is equal to Yn. So we can get this. Oops, I forgot Z and Z. And that will be useful in the next chapter. So where are we going from here? So right now we're in the medium run. We're at the natural rate. In the last chapters we were in the short run. And in the short run, the price and the expected price are not necessarily the same as we've assumed. In the next chapter, we're going to put this all together into a model where we can show, here's the short run when it's not the same, here's the long run when they are the same, and hopefully bring the first 6 chapters together into one framework. What we're going to do is really develop an aggregate demand, aggregate supply model of a type you probably saw in principles. So see you in the next video.